Good morning, ma'am. Good morning, classmates. Today, I will be discussing about ponding time. So, ponding time is the time elapsed between the time at which the rainfall begins and the time the water begins ponding on the soil. So, ito po is yung oras kung kailan nag-start na yung ulan at yung hanggang sa oras na nag-start na ng mga stagnant waters dun sa surface. Potential infiltration is the sufficient amount of water available for infiltration. Ponding time, before the ponding, infiltration rate is equals to the intensity of rainfall. Means that whatever rainfall is falling is infiltrated into the ground. After ponding, infiltration will be potential infiltration. Main and Larson, 1973, presented a method of determining the ponding time using the Green-Amp equation. So there are three principles involved. First, for time is equals to ponding time, all rainfall are infiltrated into the ground. Second, potential infiltration is a function of cumulative infiltration. The last one is, ponding occurs when potential infiltration is less than the intensity of rainfall. So the graph shown are the soil moisture content profile. Prior to the ponding time, at time is less than the ponding time, the rainfall intensity is less than the potential infiltration rate, and the soil moisture content is unsaturated. So at this time, it means that the ponding has not reached and that the moisture content is less than the maximum moisture content. At time is equals to ponding time, the soil surface is already saturated. It means that maybe depending on the types of soil, the ponding has reached. As the rainfall continues at time is greater than the ponding time, the saturated zone extends deeper into the soil and overland flow occurs from the ponded water. So, at this time kasi is parang the ground is already infiltrated and lahat na ng pores is, all the pores are already full and masyado nang mabagal mag-infiltrate siguro, possibly. That's why nagkakaroon na ng ponding. So by deriving the equation for the ponding time, we will assume that the time of rainfall is equals to the time of ponding. So at T is equals to TP, infiltration rate is equals to the intensity of rainfall, and the cumulative infiltration is equals to the intensity of rainfall multiplied by the ponding time. According to the Green-Amp equation, where infiltration rate is equals to K multiplied by 1 plus psi delta theta over F. So, since F is infiltration rate is equals to the intensity of rainfall, and cumulative infiltration is equals to the intensity of rainfall multiplied by the ponding time, we will just substitute the values to the given form equation. Then we will get this. By the way, baka ma-confuse kayo dun sa delta theta tsaka dun sa MD, sa unang reporter ng Green-Amp. Actually, delta theta is also equals to the MD, guys. Baka lang ma-confuse kayo. And so by deriving, we will get the final formula in solving ponding time, which is TP is equals to K multiplied by psi multiplied by the change in theta over intensity of rainfall multiplied by intensity of rainfall minus K. So, generally, ponding time is a function of K, which is hydraulic conductivity, psi, soil suction, change in theta, or the change in soil moisture content, and I, which is the intensity of rainfall. Sample problem. Compute the ponding time and the depth of water infiltrated at ponding for a silt of 30% initial effective saturation, subject to rainfall intensities of A 1 cm per hour and B 5 cm per hour. Given the hydraulic conductivity is equals to 0.65 cm per hour and the product of psi and the change in theta is equals to 5.5068 centimeter. So first, let's write the given. We're the in letter A, where intensity of rainfall is equals to 1 centimeter per hour. Hydraulic conductivity is equals to 0.65 per centimeters per hour. Centimeters per hour. And the product is equals to 5.68 centimeter. So, as you can see guys, lahat na actually is given. Ang gagawin na lang natin is i-input na lang natin siya dun sa formula. Kung saan yung formula of ponding time is equals to K multiplied by psi multiplied by delta theta over intensity of rainfall times intensity of rainfall minus hydraulic conductivity. So, dyan, i-input na lang po natin. Solution. TP is equals to hydraulic conductivity multiplied by the product of psi and delta theta, which is 5.68 centimeters over intensity of rainfall na 1 centimeter per hour multiplied by, again, 1 centimeter per hour minus 0.65 centimeter per hour. So, masasolve nating TP dyan, guys, is 0.65 multiplied by 5.68 times 1 times 1 minus 0.65 is equals to, so, ang ponding time natin is 10.5 hour. This is our ponding time at I is equals to 1 centimeter per hour. So, next is isosolve naman natin yung depth of water infiltrated at ponding. So, since ang ponding time natin is equals to 10.5 hour, ang formula lang natin na gagamitin ang formula lang na gagamitin in solving the depth of water infiltrated is F of P is equals to intensity of rainfall multiplied by the ponding time. So, need muna natin in solving depth of water infiltrated, need muna natin solve yung value ng ponding time. Pero nasolve na natin kanina, which is 10.5 hours. So, input na lang din. So, solution, F is equals to 1 centimeter per hour multiplied by 10.5 hour. So, F of P natin, cancel lang yung hour, will be 10.5 centimeter. Again, at I is equals to 1 centimeter per hour. So, how about naman po dun sa, if yung intensity of rainfall natin is 5 cm per hour. So, solve natin. So, letter B, which is ang intensity of rainfall naman natin is 5 cm per hour. So, lahat ko na lang ulit tong mga nabura ko. 0.65 cm per hour yung K. So, ayan, delta theta is equals to 5.68 cm. So, input na lang din ulit natin. Solution. TP is equals to 0.65 cm per hour multiplied by 5.68 cm over 5 cm per hour times 5 cm per hour minus 0.65 cm per hour. So, ang value ng TP natin at intensity of rainfall is equals to 5 cm per hour is 0.1697 or 0.17 hour. That is our ponding time at intensity of rainfall is equals to 5 cm per hour. So, ayan, isa-solve din ulit natin yung depth niya at this intensity of rainfall. So, using this equation ulit. Brain na natin. Since ang na-solve natin ponding time is equals to 0.17 cm. Ay, oh my gosh. Yes. 0.17 hour. So, ngayon, solution for the depth. Depth of water infiltrated. F of P is equals to 5 cm per hour multiplied by the ponding time which is 0.17 hour. So, cancel. Ang F of P natin is 0.85 centimeters. So, yan po yung depth of water infiltrated at intensity of rainfall is equals to 5 cm per hour. So, ganun lang kasimple guys ang pagsosolve ng ponding time. Using the Greenamp equation, we will derive a formula for the cumulative infiltration to be used on the infiltration after ponding. So, according to Greenamp equation, or cumulative infiltration minus absolute value of psi times delta theta times ln 1 plus cumulative infiltration over psi times delta theta is equals to hydraulic conductivity multiplied by time. So, at T is equals to TP. So, yun na nga, we will just again substitute TP into T or T into TP. And the capital letter F into capital letter F of P. So, ayun. So, by doing so, we will get this equation. So, let's assume na yung first equation sa Greenamp is the equation 1. And the second equation where we change T into TP and F into F of P, we'll assume it as the equation 2. So, by subtracting equation 2 from equation 1, we will get this. So, since ln A plus ln B is equals to ln A over B, the final equation for the final equation in solving cumulative infiltration will be this. So, this will be used as the final form of Greenamp equation for infiltration after ponding. So, sample problem. Calculate the cumulative infiltration at the infiltration rate after 1 hour of rainfall intensity, 5 centimeters per hour, on a silt of loam soil with an initial effective saturation of 30%. So, kung mapapansin nyo po is medyo same siya dun sa example ni Ms. Cortez, pero so, given. So, ang hinahanap dito guys is cumulative infiltration or anyways, I don't think magagamit natin yung F of P pala here. So, let's check ko lang guys. Yes, magagamit. So, ang hinahanap dito is the F A and letter B is the infiltration rate. So, yan po yung dalawang hinahanap. The cumulative infiltration and the infiltration rate. So, ang formula po na nagagamitin is yung na-derive na formula, which is ito. F minus FP minus change in theta multiplied by psi ln plus F ponding time. Yan. So, simply, mag-i-input na lang din tayo, guys, ng mga given. Kasi, andyan naman na siya lahat. So, ang F, solution, para, minus 0.85, minus 5.68, centimeters, ln 5.68 plus F over 5.68 plus 0.85 equals to hydraulic conductivity 0.65 centimeters per hour. Oh my gosh, hindi na pala siya kasya. Wait lang. .65 times ang time natin is 1 and our ponding time is 0.17. So guys, using shift solve, ang makukuha nating cumulative infiltration is equals to 0.54 centimeters. So, ngayon, ang isasolve naman natin is the infiltration rate. We're going to use successive substitution. So, ang gagamitin nating formula for the successive substitution para makuha natin yung F is formula. F is a function of time equals to K multiplied by time plus psi times delta theta again, ln multiplied by 1 plus Ft over yan. Yan yung formulang gagamitin. So, pa-take note na. So, since wala tayong value ng f of t and f of t dito, hindi natin siya masosolve. So, initially, mostly, almost all, ang ginagamit nilang f of t here as an initial is same as the value of the hydraulic conductivity. In doing so, ang time natin is 1 plus 5.68 ln 1 0.65 over 5.68. So, ang makukuha nating f of t dito guys is 1.27 centimeters. So, ngayon, dahil successive substitution, for the next, ang gagamitin mo namang, ang ilalagay mo namang f of t dito is etong value na to. Itong value naman dyan, na to, ang isasubstitute mo dyan for the next. Kasi nga guys, successive substitution to. So, ayun. Gawin natin. So, since sa una is 1.27. So, 1.27 naman dyan. First is 1.27. This is just to note. So, 0.65 plus 5.68 ln 1 plus 1.27 over 5.68. 1.80 naman to. Then again, ang gagamitin mo na naman na FT susunod is ito. Is ito. Ilalagay mo naman siya dito. So, ganun lang siya guys hanggang sa ang nearest difference ng dalawang to is it should be na ang nearest difference nila is sa 0. So, ang nasolve dito sa book na value is ang FT or ang F na gagamitin natin is 3.02 pero yung nasolve ko is 3.04. So, doon na lang tayo sa nasolve ng book which is ang gagamitin nating value ng F. Anyway, sa ano na to guys sa letter B na to. Letter B, which is F. Yan. So, ang given natin dito is ito, and F is equals to 0.02 centimeters, which is from the book ko. But yung na-solve ko guys is 3.04. So, ito na lang sa book. Baka mas accurate. Ang mga values lang or ang mga given lang na gagamitin natin is the hydraulic conductivity, and the product of psi and d delta theta. And of course, our F, which is 3.02 centimeter. This is using the convergence of successive substitution. So, F, to solve the infiltration after ponding, F is equals to K psi delta theta over F plus 1. Yan yung formula. Then, substitution na lang ulit. 65. So, infiltration na makukuha natin is ang infiltration rate natin after ponding is 1.87 cm per hour. Answer sa letter B. That is the infiltration rate after ponding. So, yan lang. Thank you for listening. I hope may naintindihan kayo kahit magulo. Bye!